So let's start. Today's topic is about Python functions. We've already spoken about functions in an earlier lesson, and that earlier lesson was actually titled pseudocode and functions. So when we talked about pseudocode and we introduced pseudocode, we introduced it with functions. So actually, a lot of the stuff that we'll talk about today, we've already spoken about in a previous lecture. The idea today is to focus on how that is implemented in Python. And actually, when we did the pseudocode thing, I think I showed you some Python then too. So the reason why I'm mentioning that is I'm hoping that this won't seem too strange to you. What I mean is I'm hoping that you'll look at it and it'll seem like, oh, I kind of remember that. So here we are, this first slide referring to functions. And this function here, we have in a symbol, which is a symbol from a flowchart. So the flowchart symbols you would remember when you see a rectangle like that, that means it's a process. This is a special process in a flowchart, I suppose you'd say, because this process is a function process, and we can tell that because it has parallel lines, a line on each side. That's, if you see a rectangle like that in a flowchart, that means that that is a function. Now, this function actually is helping us to see how we would write a function, or different parts of a function, I guess you could say. So you can see that there's a variable z that's taking a value, which is the return value from this function. Now, all of that I'll try to explain to you as we go through the lecture. When I say the return value of the function, what I mean is that function returns a value. That's the output that comes from the function. So when this function is implemented or executed, there's a output from it. We say that's the return value, and the return value can be set to another variable. That's what's happening there. Now, the other two things, the x and the y, we refer to them as arguments or parameters. Those would be inputs. They also refer to, they're going to become local variables inside the function itself. Now, this slide here, whereas the previous slide was talking about function from the point of view of a flowchart or pseudocode, this slide is specifically about Python. And so the terms that are used here are terms that we use in Python. So this is a very important one. You won't see this in other programming languages. You don't see it in pseudocode. We use this keyword called def. When we create a function, I guess we would say that we define it. And maybe that's why we use a def. Def for define. There's two steps to making a function work in Python. First, you have to define it. Then you have to call it. So there's two things. You define it and call it. The next slide that I'll show you after this, we'll talk about calling it. But here we're defining it. When you define the function, you have to use this keyword, def, and then you have to state the name of the function. Now, the name of the function, when you're defining a function, that's up to you. You make up the name. You call it something that is meaningful so that you'll know when you see that name what's happening in that function. And then the parameters that it refers to, those will be inputs that go to that function. If you're going to give it any inputs, you'll put them in a round brackets. And so every function has round brackets. It may or may not have in those round brackets some parameters, which will be inputs. The colon, hopefully you're becoming familiar with the colon. The colon we're using that in all of our different control structures in Python. So when we create a new function, we use a colon after the heading of the function. And then after the colon, everything, the different lines of code that are going to be executed in the function, those will be indented after the colon. A function may have, and this is optional. So there's a couple of things that are optional in the function. The parameters are optional. You can have a function without parameters. That just means there won't be any inputs. All right, that's fine. And you can have a function without a return. And that just means that there won't be any outputs, and that's fine. But if you want to have inputs, then you have to have parameters. If you want to have outputs, you have to have a return value. And so we have a return statement, which is optional, as I said. We can return a variable out of the function. So this word call, it's not like a telephone call. This is when we say calling a function or a function is called, what we mean is at that point in the program, we invoke or it's like an instruction to the computer to run that function. That's what we mean by calling it. It's like, okay, make that function work now. That's calling the function. And obviously, we can't call a function if we haven't defined it. So that's why we say there's a two-step process. We define the function, and then later we call it. When we call it, at that point, the function will be executed. And so you should have your inputs ready to go in as parameters to the function. And if you're going to have any outputs, you set them to take the value that's returned from the function.
Hello.
Hello, Omar.
How are you?
I'm good. And I hope you're well also. This slide I have shown you before. This came in a previous lecture. The previous lecture where we were talking about pseudocode and, or actually this one might have been about flowcharts. But I think I kind of like this diagram because we've got this rectangle box, which we now know that represents a function because it's got the parallel lines on the sides. So that's how we represent functions. I like the idea that they put black there because there's actually a term that we use in computing sometimes. Engineers use this also. We talk about a black box. So the idea of a black box is something that we know what goes into it, and we know what comes out of it, but we don't know what happens inside. We just know that this goes in and that comes out, and some magic happens inside. So that's why we call it a black box. So here in this diagram, this is a black box. We know what goes into it is assignment, quiz, and test. We know that what comes out of it is overall. But looking at this diagram here, we don't know what is the magic inside that box. Now over here on the left, we describe the magic, right? So over here on the left, this would be us defining the function. We define the function. That's where we have to say what's inside the black box. Because here we're just saying this is the function, put this in and get this out. That's kind of like a call. So the black box is like us calling the function. Over here on the left is us saying what's inside the black box. What happens inside there? Well, what happens inside is three variables come in, X, Y, and Z. Now here they're called assignment, quiz, and test. But here inside the function, they're called X, Y, and Z. So these are local variables. That came up in your quiz, or your test. You remember that? A lot of you got a question about local variables. The local variables are only used inside the function. And remember, we talked about memory in the computer and the memory stack. When you invoke the function, you put these variables on the stack, and they only are there as long as the function is running. Okay, so we got our local variables, and here they are, X, Y, and Z, and S and A. X, Y, and Z are they come in from these global variables, and then S and A are created and only live inside the function. Very nice. This is not Python. What you're looking at in this slide is pseudocode, but it wouldn't be very hard to convert this pseudocode into Python. The structure would be exactly the same. We don't use the word function in Python, and we don't have to state the type of the variables. We also don't use curly braces. So if we took away the word function and replaced it with what? The keyword that we talked about 2 slides ago, I guess. The keyword when we create a function is def. All right, now here, if you were using JavaScript, you would say function. All right, because that's how you create it in JavaScript, but we're not. We're using Python, and so we do def where that function word is. Now, the other thing that's different is we don't have to say the types of the variables, and we don't use the curly braces. in Python. The curly brace is going to be replaced by what? The first curly brace is going to be replaced by a colon. So we put a colon right there where that first curly brace is. We don't need the last one at the end, but the indents would be the same. So your Python code would look a lot like that. And actually, so I went through that a bit too quick. The next slide is, this slide here is the exact same code we were looking at a couple of seconds ago, but the code we were looking at before was in pseudocode, and this is translating it into Python code. And so here at the top, we got our special keyword DEF, which is defining this function. This is the name of the function. The name of the function is average grade. This function takes as inputs 3 different parameters. Here they're called X, Y, and Z. And what happens is then there's the colon, right? So then all of this stuff is indented from the DEF. So these are the code that are part of this function. So what happens in this function? This function creates a variable S, which is only used inside the function. And what it does is take the X, Y, and Z, which are passed in as inputs, adds them together, and then that total is stored in S. Then there's a new variable that's created, which is called A, and A, it takes the value of S divided by 3. Now, the return statement at the end means that when we call this function, this will become the output. A will be output from the function. Now, I said when we call this function, where do we call this function? You can see it by the colors here. It's kind of nice, I guess. But here we are calling the function. Now, notice in the function call, we create a variable called AVG, and it takes its value from the return or the output. What this means is this function is outputting a value, and that value will be stored in a variable called AVG, which will then be used to print it out. And so the 2 steps, we define the function, and actually we see these 3 lines of code before the call. This is the function call, and then 3 lines of code before the function call. What they're doing is they're just getting the 3 variables that are going to be used as inputs to the function. So we get an assignment, we get a quiz, we get a test. We use those as inputs in that function. When the function is called and executed, assignment lines up with X, quiz lines up with Y, and Z lines up with test. The order of the variables is important. I mean, you can't sort of mix them up. This is how it is, right? So basically it's first variable, second variable, third variable. And when we do the function call, first variable, second variable, third variable. And so here we've got these do have meanings, but they're all going to be numbers, and then they will be added together and we'll get an average from them. So there's a lot of functions in Python, and a lot of functions that come with function. You can make your own. So that's what we've been talking about for the last few minutes, is how do we make our own functions? But there's functions that you don't have to make. You can just use them because they're already there. And that we call those our built-in functions. So you've used some of these. We have these casting functions. Now what happens with the casting function? Okay, this is just black box stuff. We don't know what's happening in there, right? Somebody wrote these functions for us and we use them as a black box. But we know what's going in and we know what's coming in. So what goes into the int function is we put a number in there or a string. It could be a number or a string. So the input, the X, is going to be a number or a string. The output is going to be an integer. So the int function outputs an integer. The string function, well, what do you think it does? You can put any bunch of characters in there. So typically you're going to take a number and that will be the input, and the output will be a string. Likewise for the float, typically we put in a string or we put in an integer, and the output will be a float value. Right, so next one down, the len function. Input is going to be, the X is going to be a string, and the output is going to be a number, which is how long is that string? It'll be an integer number. Input X, we've done these. input X and print X. We've done these, right? So in this case, the X's are both strings. With the input, the X is just going to be a prompt that's going to come up on the screen. You know, please enter your student number or something like that. And the output will be that the string that the person types on the keyboard. Whatever the person types on the keyboard you'll be able to use it. You know, maybe save it as a variable or something. The print function. Okay, so here's a function that has an input, but it has no output, right? There's there's no returned value. But what happens? But it's not right to say it doesn't have an output, I suppose, because what happens with the print function is it will put whatever that string is, whatever that string X is, will end up being put onto the screen. So the print function puts something on the screen. Now we got some other functions down here. Absolute value function, you input a number and it gives you the absolute value. So if you put a number -2, it would output +2. Power function, you put in 2 variables are the inputs, and it will take the first variable as the base and the second variable as the power. So for example, if you put in the numbers 5 and 2, then 5 would be the base. So 5 squared, 5. So it would return the value of 25. ASCII is a special one because ASCII is how our computers with their operating systems, how they're able to convert the inputs that are able to sort of communicate with the operating system. We have a range of numbers from 0 to 255, which are mapped to all the different characters on your keyboard. And it's the characters, not just the letters of the alphabet. It's not just A, B, C, D. It's all these other special characters. Each one of those special characters in every letter of the alphabet and every number 0 through 9 has a mapped number between 0 and 255. And so what we can do is we can put in with the ASCII function, you put in the character as the X is the character, and it will return for you the ASCII number, a number between 0 and 255. The CHR or character function, the input is going to be an ASCII number, and it will return for you the character which maps to that ASCII number. Bin, the input will be an integer number, and the output will be the binary number that translates from that integer number. Hex, the same. Input an integer number, and the output will be a hexadecimal number that is translated from that. All right, the idea of libraries. So programmers write functions. You'll write functions, but we've got programmers all around the world writing nice sets, or I guess you could call them suites or libraries of functions to do special things. And so as the computing world evolves, we get new libraries to do special things. So you can get a library which will help you to sort of work with the API on Twitter or something like that. You can get a library to help you manipulate that. Whatever it is, the new thing that we want to work with, somebody will have a library somewhere. Now, there's some libraries that are sort of just built in with the distribution that you have. When we install idle on our computer, we get a math library. All right, so it has a bunch of math functions in it. We use some of those, but there's other functions, as I said, that might be very specific to some engineering idea or some social media idea or some graphics idea. And those functions, you might have to go and find them out on the internet somewhere and download them, or you might be able to just reference them by a URL to say, I want to use that library. But when we go to use a library, we have to get it into our computer memory before we can use the functions that are part of that library. And we have a special command for that, and it's called the import. So you'll see in the programs that we're using here, we use the import to basically load up into the memory that particular library so that we can call the functions on it. So for example, if we wanted to calculate square roots, or we wanted to use the number pi, we would need to use the math library. So we'd have to import that math library, after we imported the math library, we could go ahead and use those. And here's an example of that. So here we're calculating the square root and what else? The area, the radius of a circle, using special math functions. Notice here, at the start of that little program, the first thing that happened is imported that library. If we didn't import the library, then that wouldn't work. Right, some other functions. We have these things called objects because Python is one of many different object-oriented programming languages. So Java is an object-oriented programming language. Python's an object-oriented programming language. What that means is you can create objects, and then objects can have methods or classes associated with them. And so a method is going to be instructions that work with that type of object. Now, that whenever you create a string, now we've used strings, right? String is like a bunch of words or letters and whatever characters strung together in an order. So whenever you use a string, that is an object. And so string objects can have methods that are associated with them. And we've used some of those. The ones here in the first sentence, we've used them. Remember, we've used the upper, the capitalize, and the lower methods. I'm using the word method because a method is a function that works on an object, okay? And so you have to call it in that way with this dot. Now, the dot is not the start of that function call. The start would be the name of the object. So the name of the object would be, for example, well, it has to be a variable. So it has to be a string. So typically you're going to store a string in a variable. You'll create a variable string, a string variable, and then you'll store the string in that variable. And then you can attach these methods to it. If you do dot upper, it'll convert everything to uppercase. If you do dot lower, it'll convert everything to lowercase. If you do dot capitalize, it'll convert the first letter to uppercase and all the rest of the letters to lowercase. Now that's different than these red ones. So this thing here, what this is doing is actually converting the string from one way to another. A few seconds ago, I talked about ASCII characters. So the ASCII characters are 0 through 255. These numbers, I think the number A, you got capital A and then 97. So it's like that. So the ASCII characters, big A is different than a little a, right? So if you're going to convert an uppercase to a lowercase, you change the ASCII characters. Okay, so sometime, just for your own reference, I recommend you do a Google on the ASCII character table, and you'll see these numbers. This is just from my memory. I think that's right. That those are the right numbers. But yeah, so the point that I'm trying to make is this is different than this. They're not the same. All right. In the computer memory, they're stored as different things. All right. So this is not equal to this. Okay, they're not equal. They're different things. And so you can convert them. But also we can know if something is upper or not. What these things do, these functions, they are Boolean functions. Now, you know what Boolean means now, I think. Boolean means that it's going to return only two possible values. It's either going to be true or false. And so when we use these functions, what it'll be is it'll be true if the string is all uppercase letters. Is upper is going to be true if they're all uppercase letters. Is lower is going to be true if they're all lowercase letters. Otherwise, it'll be false. Is numeric is going to be true if whatever is passed into it, sorry, not passed into it. So if the object from which it is attached, which is going to be a string, if that string is all numbers, then this will be true. So I'm sorry, I don't want to confuse you. These are all functions, methods that work with strings. They're string methods. So we have a string. So, I mean, it would be like this. We'd say my string
What's the use of
value
these
of
red
input.
functions?
Enter string, and then we
I
could
don't
say
think I'm audible.
my string dot is upper. Then we could print, well, that's uppercase. So that's how we use that. So see, this is, you know that in an if statement, this is going to be a condition. So we're saying this is either going to be true or false. Does that make sense? That's how we would use that. Maybe we can try that a bit later. So these are either going to be true or false. You know, it's either up or it's not. It's either low or it's not. It's either numeric or it's not. Numeric means that everything in there is just numbers. Alphanumeric, or sorry, is alpha means that everything in there is letters. Is L-num? L-num means that it's a mixture of numbers and letters. Right. The print function. So I mentioned before that. So how are functions working? They have a parameter, right, that you pass in. That's the input, and they can have a return value or not. The print doesn't have a return value, but it has a parameter, which is going to be the string that we're going to print. But we can also have some special things that we can put into our print statement. If you put a /n, what that will do is at that point, it will give you a new line, goes down to the next line. Or instead of that, we can do this n, which will mean that where normally we would have gone to a new line, we can do something else instead. We can put a space in there or a comma or something else. And here's our example of that here. I've got somebody's trying to say something. What the use of using these functions in a program? Not sure what you mean by that. The previous slide. These functions here. I think these functions would be really good for, like, if you wanted to test a password. Maybe you could have some rules on a password that passwords have to have a mixture of alphanumeric, right? Have to have numbers in them, that kind of thing. So you could find out if it is. You could see if it's uppercase or not, that kind of thing. So if you wanted to test out a string that it meets certain requirements, then these functions would be very useful for that, I think. So here's the example of this, and I think I've shown this to you before, this n thing. So we've got a string here in this print. We're printing hello, and then after that, we've got a comma, then we say and equals, or equals, then we've got just a space. What that means is, instead of, when we finish printing this line, instead of going down to the next line, we're just going to have a space. And so the next line will be printed up on the same line as this. And so when you look at the output, that's what you get. These two things, which should be two different lines, actually end up on the same line. And so that's done with this end equals. So the end equals thing just basically means there was a carriage return or a new line here, and we're removing it and just replacing it with a space. And so that would be useful for something like that. Oh, I'm not going to trace this here because I think we've got a nicer one, a couple of slides on, where we do this with a loop. So we'll go to that and do that. But let's look at this and see if we can see the standard format for using a function. The first thing that we do is and I'm sorry, I keep losing my cursor in this in PowerPoint, so sorry about that. The first thing that we do, well, we import math here. Why do we import math? Because we're using some math functions. So we have to import math first. Then we define the function. You must define the function before you can use it. And then later in here, we are calling. This is the function call here. And notice that this function returns a value. Now the value here is going to be the area, but here inside the function is just called A. But then this function returns a value of area, which can then be printed out. So here we have a function, another one. This one, we have an input of a side. We square the side because it's a square. So we're using the math power from the math library. There's a function there called power. The s is the base and the 2 is the exponent. So we take the side and we square it, and then we return the area. Now, I'm going to do this with the next slide because it takes this and puts it into a loop. So we can do this 5 times. So let's see that. That's this one here. So same as before, we calculate the area where we put the side in, we square it, and we return the area. But we're going to do that inside a loop. So here we are getting a side from the user. Then we are calling the function, which we've defined up here. We define the function first. We call the function here, and we're going to do it multiple times. And I think you'll see that that's the end of the program. So let's do that as a idle program. And that'll be, so this was square 5, I'll call it. You need to do that as a comment. And I'll just put that all in there. So we're using the math, so we need to import that first. Here's our declaration of our function, where we define it. The name of the function is area squared. It has one input or parameter, which is s. Inside the function, a new variable is created, and it takes a value of the result of this power function, which is just going to take the side and square it. Then that's going to be the return value or the output of that function. So the program actually starts here. How we can do that is we can put some program numbers on here. So you can see, I'm going to put here, this is just the line numbers so that we've done this before, I think. Am I right? Have we not done this before? I think so. So what I'm going to do is I'm going to do a print here, and we're going to print the line number, which is going to be line 4. And maybe we can print the area there. It's not area at the moment, it's just A. So we'll print that. Then this is going to be line 5. Here we go, line 6. 7. Okay, so when you're doing things like this, because I did a copy paste, notice that the quotes are different types. This type of quote doesn't work. So I'm just going to remove that and put in the right type of quote. And we know it's right now because the color changed. So that's line 8. Line 9.
So why is the line 8? Why is in print quotes?
Because I want to print it on the screen.
But you don't want to print the others on the screen?
Well, I don't. If I wanted to print the others on the screen, I'd have to use a print statement, and I could, but then I'd be up here typing longer. And you see how slowly I type. So that wouldn't be a good idea. But what we should see, the reason why I'm putting the line numbers in there is so that you can see that the program starts here. The program actually starts, well, we got the count. Maybe I could, no, I don't want to do too much more typing. Let's just run it and see. So this is square 5. So we can just, this is going to happen 5 times. Now, what I want you to notice is over here in the side, you asked me about the line numbers in green. These were all the line numbers in green. Now notice it starts at line 8, then goes to line 4, then goes to line 11, then goes back to line 8. See the pattern? Line 8, line 4, line 11. Keeps doing that, right? Keeps doing it. 8, 4, 11. 8, 4, 11, 8, 4, 11. It's going to do that 5 times. 1, 2, 3, 4, 5. 8, 4, 11, 8, 4, 11, 8, 4, 11. So why did it do that? Why did it go 8, 4, 11? Let's see. 8 is here. The program actually started over here at line 6. That's where the program started. Well, actually, it started here at line 1. But this stuff here, this does not happen until you call the function at line 9. So it was after line 8. You'll see that the line 4 is printed after line 8. Line 8, then line 4 is printed. Line 4 is always printed after line 8. Why is it always printed after line 8? Because at line 9 is where we called that function. And this print is inside that function. And so it couldn't happen until we called the function. This is the function call. The function is called here. This is the function definition. We defined the function here. We called it here, right? This is the start of the well, yeah. I was going to stay start here, but the import is actually a Python statement. But the import is not actually doing anything except loading up that library into the memory. It's loading up the library into the memory. So anyway, so that's kind of it for tonight. I think I'm going to leave it at that. Yeah, any questions? Well, let's see who's here. People that are here but not here. So that's Aisha, Farida, Hafsa, Omar, and Zobia. Welcome. Any questions? Okay. Well, I'm going to stop the recording then. Just see anybody. Yeah, those people are still there. Yeah. Okay, so there's no questions, so I'm just going to end there, and I will upload this to D2L.